We are working on the welcome message project from the YByte Python curriculum available at www.ybyte.in. We saw previously how we had a very flexible function, short form, where I could give any number of arguments and this function will keep working. For example, here I'm just calling my short code to create a short form from, let's say, Vineet Bengaluru Intelligent YByte. I mean, just an illustration. My short code, in fact, is if I look at short code, that is VBIW. We have seen this in detail earlier. This function is flexible because of this non-keyword argument with the star, and that gets interpreted as a tuple, and then the magic happens. However, whenever we open up a function to somebody, some other person using it, there's always a possibility of having some errors. For example, let's say my user, instead of giving all the arguments as strings, let's say my user by mistake gives an argument, let's say 34. Just illustrating this as a number, it's not about 34, it's about the fact that one of the arguments is no longer a string. Now, when I run this piece of code, notice I get an error. It says that, look, there's a type error, which means that, the integer object that I passed in caused a problem. Why did this happen? Well, the reason this happened is because, remember, inside this function, I am running a for loop. This for loop goes through every item on this tuple words, and it looks for the first character of this. Now, clearly, if I have an integer, then I cannot do, let's say my integer is 47. I cannot do 0 because integer objects are not like lists or strings where I can put a subscript, because that's just like basically just one number. So now the problem is that, look, because of my user's, let's say, mistake, if you will, because the user passed an argument which was not suitable for my function has crashed. This is something that we encounter a lot, in fact, and in fact, we have dealt with this before. I'll give you examples later just to sort of recollect some of the things. But, the simplest and let's say the most, the most basic way of handling this would be that, look, when I get into this function, I just ask myself, look, where is it that things can go wrong? And I can put that in what is called as the try and except block. So I can just go and say, well, let me just try this piece of code. Now, typically, try and except, the syntax is quite similar to, let's say, the if else, in the sense that there has to be try colon, indentation for the code that's inside the try, and then finally, then let's say for except, again, except colon, and some code for what happens in except. Now, in this case, notice what I'm saying is that, look, let me try. Please, or rather, I'm requesting the interpreter, please try to do this. I know this is a little bit risky, hence there may be an error. If you succeed, very good. If not, worry not, just run the code that is on the except. So, I can say, for example, say something went wrong. And I can run this code. Now, for now, just for now, I will, comment out the return part. We will come back to this a little bit later, but here I want to illustrate to you what try and except does. Again, we have seen this before, so this is really like a revision. When I do this piece of code, let's say I run this again. Notice again, if I called my function short code with, let's say, short form Vineet Bengaluru Intelligent 34, this does not crash anymore. Notice previously my function had basically crashed with a type error. Now what's happening on the other hand is that, well, my function is gracefully getting out. It's telling me something has gone wrong. The important point to understand is that this error is like a runtime error. This is happening because I'm getting an input, which is something that I did not expect. So rather than crashing from it, my code is now robust. It just comes out gracefully saying that, look, something has gone wrong, implicitly telling the user that please check your inputs that you're giving. Of course, as we'll go further, we'll see we can make this a lot more clearer for our user. And like I said, one of the goals of, let's say, a program like this is also to give error messages to the user in a nice way, right? Now, something went wrong is actually quite general. It doesn't really help, but, we can make this better as we go on. Just to take one more example, let's say, look at the other function here, sum. Now, this expects all numbers. I will end up in an error. So if I do sum 1, 2, 3, that's not a problem. But the moment I do sum 1, 2, 3, A, B, C, in fact, an exact similar error will happen, because when I'm adding an integer to a string, that is a problem, right? So it's similar. It's very similar, just that the nature of error is a bit different. Again, I could have put a try and except to handle this. So the broad point is, when I know that certain piece of code is vulnerable because errors could happen from coming from an outside world, I can put that in a try and except. Try this. If it works, very good. If not, worry not. Well, just print something here. Now, for a moment, you might wonder, why don't I use if else for this? Well, the reason is this, right? If I were to do if and else, I won't have a way to come to the except situation, right? So either go into if or I go into else. So that's why try and except is better for this situation. In fact, as I said in the very beginning of this video, we have done this ample number of times before. A lot of students, for example, when we built the missing operators project or the birthday countdown project or even the number hunt, even shopping cart for that matter, whenever we are asking inputs from the user, a lot of students are using, let's say, try and accept to earn bonus points. That's because, for example, here, let's say the user gives something which cannot be converted to an integer. So we can try this. If it doesn't happen, we can remind the user, okay, look, please don't try to, let's say, give me some wrong inputs, right? Similarly, in birthday countdown, we may get non-integer values. We may get a situation where the values are okay, but they don't create a proper date. For instance, I might want to create a date which is 35th of January. That does not exist. That will get caught in this position. So there, it was all bonus. We, in fact, made this a part of our project in calculator, because once again, calculator, remember, we have let's say a bunch of buttons. The user is creating an expression. The user can very well make a mistake. For example, divide by 0. For example, leave the expression incomplete. If any of that happens, I try to compute the result. However, if that, the result is incomplete, I just come into accept and I say, look, there's been an error. So we have seen this before, but going forward in this set of videos, we will definitely go a little bit deeper than this. I hope you found this interesting and you're seeing how the thought process forms, around such activities. In general, if you think learning this way is a good idea, well, look at our website, www.ybyte.in, because this is how we learn Python programming. Thank you so much. Take care. Bye-bye.